Welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to look at Igcse physics revision. What mattered, or what was important, what mattered in June 2024, and exactly what you are supposed to have studied. At the opening of this particular video, we are going to mention that longitudinal waves are a type of waves where particles vibrate parallel to the direction of the wave. Example of longitudinal wave is sound wave. If you're new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload a tutorial, you'll be notified. Take this chance to leave a comment down below, and also you can give a particular video a like. What matters most and what mattered most, what was important most in the paper of May-June is you understanding that the moon orbits around the earth. So you are expected to draw the orbit of the moon around the earth, and you need to understand that the orbit of the moon is circular and the orbit of a planet is elliptical. So the orbit of a comet is more elliptical than the orbit of a planet. For a comet and the planet, they orbit the sun or the star, but the orbit of a comet is more elliptical. So what mattered most in its exam is for you to understand the moon orbit the earth, and then its orbit is circular, and that is exactly what I have displayed here. This is the moon orbiting around the earth. But I've given this information so that in the next exam, if they ask you to draw the orbit of the comet, you understand what you are supposed to do. When you are asked to give the difference between the orbit of a comet and orbit of a planet, orbit of the comet is more elongated, more elliptical. Orbit of a planet is just elliptical. If you are asked to give a difference between orbit of a comet and the moon, you'll say the comet orbit the sun while the moon orbit the planet. I think that's enough for you to understand. You need also to understand that the type of force that caused the moon to orbit Earth is called the gravitational force. And another object that orbit the Earth, orbit the Earth is a satellite. Satellite can be man-made, but the natural satellite that orbit the Earth. So in this case, as a student, you are supposed to say satellite, all space stations, all space stations. We are supposed to give difference between orbit of planet and orbit of a comet. Orbit of the comet is more elliptical, is quite elongated and stretched, but than the orbit of a planet. What also mattered most in May-June exam 2024 is you understanding that the atomic number is the number of protons. Mass number is equals to atomic number is equals to the number of protons. Mass number equals to protons plus neutrons. Also, you had to understand that isotopes are atoms of the same element with same proton number or same mass atomic number, but different number of neutrons. Remember, if you have isotopes, isotopes have the same proton number. For instance, these are two isotopes. These are isotopes because they have the same number of protons. These that have 8 are also isotopes. But the mass number is different, and what brings about the difference in mass number is the number of neutrons. So in this case, the correct answer is supposed to be A, because this had 8 neutrons, but this one has 6. So the correct answer here is A. Which type of radiation is high energy electrons? The fast moving electrons are better. Alpha is a helium nucleus, and gamma are electromagnetic waves. You also are supposed to understand which type of radiation does emit when the mass number decreases by 1. This is actually neutron, right? If the mass number decreases by if the mass number decreases by 2, that is alpha, and if the mass number remains the same, and that is actually beta. But if it's emitting gamma, there is nothing that changes because that is just the nucleus is just looking. I believe you are getting value from this particular video, and if you are new to Proflan, consider subscribing so that I'm going to upload the next part, you'll be notified. Moving to the next part, you are told that the nucleus of an isotope of uranium can be represented. So what you need to understand, the number at this top is called the mass number, and the mass number we said is the number of protons plus the number of neutrons. Atomic number is usually written down here, which is 2. And the number of the atomic number is equivalent to the number of protons. But if you are asked how many electrons, what you need to understand is that protons is equal to the number of electrons. So since we have 92, since we have 92 protons, then it means we have also 92 electrons. But if you are going to be asked in your exam, May, June, this time round, if they're going to ask you how many neutrons do we have, the number of neutrons is going to be 38 minus 92, going to give you 146. All right, so that is quite important. Then now moving to the radioactive isotope, which is having the radioactivity of 400 becquerel. If the half-life is 8, if they're going to ask you what's the half-life, what are you going to say? Just leave a comment down below. What's half-life? Leave a comment in the description below. Remember, half-life is the time taken for the activity of a radioactive substance to decrease by a half, or the time taken for the mass of a radioactive substance to decrease by a half. So if we have half-life 8 hours and we are asked to write what's the activity after 16 hours, we need to know how many half-lives are in 16 hours. We shall take 16 divided by 8. We have 2 half-lives. So meaning this radioactive substance or radioactive isotope is going to decay 2 times. So the first decay will give you 200. The second decay is going to give 100. So the correct answer is E for Kate. Give the harmful effect of infrared waves. You need to understand how affects people, how microwaves affect. Microwave cause internal heating of body tissues. Yes. X-rays and gamma rays cause what? Cancer. But infrared, they cause skin burns. Now, what mattered most also during this exam is to understand similar properties between electromagnetic. So in this case, the similarities between visible light and infrared waves is both of them they question, both of them they transfer energy, both of them they are transfers in nature, both of them they undergo reflection, refraction, and diffraction. Both of them will continue. The list is endless, but you're supposed to give on it. So, and then when you're asked to give difference between different electromagnetic waves, you need to give difference based on the wavelength and frequency. So we can say infrared waves have longer wavelength than visible light. Also, infrared waves have lower frequency than light. Don't mention uses here. Don't start comparing the impact at this particular point. I believe as a prof learner, you have understood how you're going to approach that. The infrared heating lamp are placed 1.5 meters and then we are supposed to calculate the time taken infrared waves emitted from the lamp to reach the car. Now, something you need to understand, the infrared is an electromagnetic wave, so it travels at the speed of light. So we are supposed to speed is equal to distance over time, and if you rearrange the formula, this is what you are to obtain, and working it out, you get 5 times power quite fast, right? Moving to this question, you are supposed to identify the main. We are told that this question is about stars, and in the main sequence star, a main sequence star is created in collapsing. The table gives for the gases in collapsing gases collapse from when the nebula start to collapse to just before main sequence. So complete the table by ticking or placing a tick. Show how whether they so increase or decrease. For chemical, we're going to see increases, and then we're going to talk about nuclear energy, see the thermal increase. But we are supposed to give the property that determines whether it becomes a red giant or supergiant. Remember the initial mass of the nebula. If it was very, very massive, that as a protostar, move to the main sequence, becomes a red giant, super red giant, become red supergiant, then it becomes a supernova, which now explodes to become either a neutron star or a hole. But if it was having less mass or similar mass to the sun, that type of star will move from protostar, main sequence, red giant, it cool down to become a white dwarf, and finally a black dwarf. So mass is quite important in that case. Then we're supposed to discuss differences between red giants and white dwarfs. Remember, red giant, white dwarf, and those are the evolution of stars. So when a star moves from a red giant to a white dwarf, it's almost going to die as a black dwarf. So it means that the red giant has greater brightness because it's large. Because a red giant is large, it's more bright. It has greater brightness than a white dwarf. But we are also going to realize that inside the red giant, there are some nuclear reactions, and those reactions are of helium and helium, and which result to the formation of heavy metal. When all the energy, all the helium are used up, the red giant, then it collapses, become a white dwarf. So what you need to remember, inside a white dwarf, there is no reaction. So that's another difference. Red giant has lower surface white dwarf. Because the red giant is so huge, then it cools down, so it has less surface temperature than a white dwarf. A white dwarf has planetary nebulae, because as a white dwarf, as a star evolved from a red giant, it becomes a white dwarf, which becomes planetary nebula. So on the surface of a white dwarf, there are planetary nebulae, which finally generate more stars. To the end of this part, I'll wish you the best of luck. Upload and check in the description of this link that will start. If you are new to Proflan YouTube channel, consider subscribing. So time I'm going to upload an tutorial. Right. Okay, now this is part 2 of this particular video. I would like to take you through the rest of the part of this paper. But before that, as our tradition in Proflan YouTube channel, we usually have an opening remark. Cell evolution is going to take two parts. If we are talking of a low mass star, it's going to start by the formation of a protostar. Remember, a star is formed when gas and dust particles, called nebulae, is drawn together by gravitational force. Gravity pulls these gas and dust particles, compresses them, increases temperature and pressure, and then fusion of hydrogen and hydrogen begin. Then the star starts becoming a star at that point, and the first stage is called a protostar. When there is nuclear reactions taking place in the core of a protostar, there will be outward forces. And also remember, there is inward forces of gravity. And when outward force is equal to inward force, the star moves to a stage called the main sequence, which is a stable star. Now, when all the hydrogen is used up, because nebulae comprises of hydrogen, when all the hydrogen fused and is used up, now the star collapses again at its own gravity, and then it's again compressed, and temperature and pressure increases for fusion of helium and helium to begin. And then when helium and helium fusion begin, there is enormous amount of energy generated, then the star expands to become a red supergiant. When all the helium is used up, the red supergiant cools down to form planetary nebulae, and finally becomes a white dwarf, which finally becomes a black dwarf. But if it was a massive star, a star will move from a protostar and it becomes the main sequence, which is very bright. And then when all the hydrogen is used up, remember the star will collapse against its gravity. And then now once it's compressed, when all the hydrogen is used up, gravity, there will be no outward force. So the star will collapse against its own gravitational force. Then fusion of helium and helium begins. Then that star now becomes to another stage, which is called a red supergiant. From the red supergiant, this becomes a supernova, which is an exploding star, which explodes to form either a neutron star or a black hole. It will form a neutron star if it was just massive, but if it was very, very massive from the initial stage, it becomes a black hole. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload a tutorial. Now, moving to the next question here, the question that was tested here is the concept of Hooke's law, and we are told to sketch a graph to show the spring obeys Hooke's law. If you want to show that the material obeys Hooke's law, it should be a force against extension graph, and it should be a straight line. That means it obeys Hooke's law, meaning that extension is directly proportional to the force applied. Now, if it does not obey Hooke's law, you are going to have a nonlinear line, a curve. For instance, a rubber band will behave this way. So if you are asked to state how does the graph show that the material obeys Hooke's law, is when it's a straight line, right? Next, we are going to look at the diagram which shows an object suspended from a support using a metal spring. The object is initially at rest. The object is pulled down and then released. Is pulled down, so meaning the forces will be acting. There will be a downward force, and then there will be what? Upward force. Remember, weight acts downward. So when it's released, we are supposed the resultant force will be the difference of 3.2 and 2.4. So meaning 3.2 minus 2 shall have the resultant force of 1.2, which will be acting upwards. I was just using an example here to explain to my students that if we have a box of 2 kg and there is a force of 10 Newton pulling this side and another force of 2 Newtons this side, the resultant force will be the difference, and the direction will be towards the right, towards the greater force. Next question is, the object has mass of 0.2. We are supposed to calculate the acceleration. We have already worked here the resultant force, right? Then if we are working out the acceleration, we're going to say the force, and the force we are talking about is the resultant force that we are having here. So we are going to say force equals to mass times acceleration. We know the mass, we know the force, we know the mass. Force is the resultant force, don't forget. Then we're going to apply that formula, and we're going to say force equals to ma, 1.2 equal to 0.2 times a equals to 6 meter per second square. There will be a greater downward force. So the moment it's released, there will be a greater upward force because the tension will be so strong that it will pull the object to move up. So the moment the object starts moving upwards, the speed of the object will increase, and that point air resistance also will increase. And remember, resultant force will be tension subtract the weight. So if there is another force which generated when the object starts moving, which is air resistance or drag, then it means the resultant force is acting upward, but the resultant force will be decreasing due to the increase in the drag or air resistance. When resistant force decreases, it means the acceleration of the object is going to decrease to 0. Remember, the object, as the object moves up, tension also will be decreasing while the weight remains constant. So that's why I say that when the object is released, resultant force is acting upwards. As the speed increases, air resistance also increases, so that the resultant force decreases. So if resultant force decreases, the acceleration of the object will decrease, right? Now, the next question, number 6, was a question for magnetism. So something you need to understand is that the fields are spreading away. They are moving away from each other. When the fields are apart, it means that's a weak magnetic fields. Near the poles, the fields are very, very close. They are close, meaning the strength of the magnet is strongest at the poles, right? And something else you need to remember is that the fields usually point from the north to the south pole. So you need to understand that the field usually point from the north to the south, and the fields do not cross each other. Those are some of the properties that you really ought to understand. Now, which of this is attracted by bar magnets? Remember, those materials which are attracted by magnets are called magnetic materials. So nickel is one of the magnetic material, plastic is non-magnetic, zinc is non-magnetic, copper is non-magnetic, wood is non-magnetic, glass is non-magnetic. You need also to understand, as you are going to your exam, that we have materials called soft magnetic materials and hard magnetic materials. An example of a soft magnetic material is iron, and example of hard magnetic material is steel. So soft magnetic materials are those materials which are easily magnetized, but once magnetized, they lose their magnetism quite fast. And those materials are used to make temporary magnets. Hard magnetic materials are magnetic materials which are difficult to magnetize, but once magnetized, they retain the magnetism for a long period of time. So which means these materials are used to generate permanent magnets. Explain how the magnetic field show this. What do they want to show? The strength of the magnetic field changes as they distance from the south pole. You see, as you are moving from the south pole, I want to show you, as we are moving from the south pole, the fields, the spacing increases, meaning the strength of the magnetic field decreases, right? So the spacing of the field line increases, and the further the field are from each other, the weaker the field strength is. So equally, if I'm having magnetic fields which are like this, yeah, when they are close, it means this strong magnetic field. Which when they are apart, it means they're strong, weak magnetic fields. Now, moving further, we are told that the piece of iron become magnetized. This iron is a magnetic material. So when it's put in a magnetic field, we say magnetism is induced in the ion. So which means that a north pole is generated at this side, so that it can be attracted towards what? The south pole. But when this magnet is removed from the magnetic field, it stops being a magnet. So you need also to understand the law of magnetism, that like poles repel and like poles attract. If you are new to Proplan YouTube channel, consider subscribing so that in time we are going to upload further tutorials, you'll be notified. Now we need to explain why the piece of iron experiences a force toward the south pole. It experiences a force because when this ion is placed in a magnetic field, a north pole is induced next to the south pole. Then there will be attraction according to the law of. The student suggests the piece of iron is now a permanent magnet. The student is very wrong, because if this magnet is removed from inside here, it will cease being a magnet. So we can be able to say iron is a soft magnetic material, so it loses its magnetism quite. Right, so we need to move to electricity. And in electricity, we are told the diagram shows a domestic lighting system circuit, that is, and you can see we are given some currents here. This is the main supply of 230 volts. I was just discussing with my students when you are told milli means 10 power negative 3, mega means 10 power 6 million, kilo means 10 power 3. So those are quite important aspects you need to understand. Explain the advantage of using this circuit for this domestic lighting. So if you look at this circuit that we have here, this circuit is a parallel circuit. So meaning if one cell or rather one switch is open, the other switch, the other lamps will continue working. So which means that these bulbs and lamps can work independently from one room to another, because in a house you don't want a situation whereby if one lamp goes off, the rest are off. So parallel circuit has an advantage in that if one is off, the rest will continue working, and also all the lamps are going to having the same amount of voltage in a parallel circuit. So we're going to say the lamp works independently such that if one goes off, the rest of the lamps will continue working because it's a parallel circuit. Give the name of the charged particles that moves in the electric current, that is electrons are the one that are flow. So when electrons flow, when charge flow, that is the flow of current. We need to also look at what power is. We are told show that the lamp one has a power of 5 watts. We know that power is equals to voltage times current. Now you can see the amount of current that is here is 22 times 10 raised power negative 3, which is 0.02. But the voltage is to that because all these bulbs will be sharing the same voltage, which having the same voltage, which is 230 volts. So each of the bulb will be having the same voltage because this is a parallel circuit. So in order to work it out, we are going to say that power equals to IV, which means that 0.022 times 230, and that gives us 5.06 watts, which is equivalent to 5. watts. Calculate the energy. Remember, energy is equals to power times time, and time has to be in seconds. Working it out, this is exactly what we are going to get as 150 joules. And we are supposed to state what's meant by the voltage. This is the energy transferred per unit charge. Unit charge. Yeah. If you are asked about EMF, EMF is the amount of energy transferred or supplied to move a unit charge around a complete circuit. Switch 1, switch 3 are closed, which turn on lamp 1 and 3. Switch 2 is open. Calculate the current. So you need to understand that current will combine. So if switch 2 is open, meaning current will not flow here. So the current we shall have, we just take this part and take this route, combine together, and that becomes what? 39 milliamperes. Milliamperes. Watch out for the third part of this video so that we can be able to do the final bit.